Now we will execute some of the Challenger descriptive statistics commands. Here is the script that we wrote. Now we can execute these line by line. Notice the number signs over here. This means this is a comment. So first I want to enter the temperatures. Notice I called this command temp. Select. Command enter return. And now I've entered temp. Let's display it. Just type the name. In this command, I can either leave the comment in or not when I do it this way. Press enter. There are the numbers. At this point, I would usually check to see that I have the right values. Remember the table command? Command return gives me all the values that occurred and the number of times they occurred. I can actually select any number of commands at one time and run them all. So here is the cut command, which divides the 36 temp values into blocks. 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. Now, how about a stem and leaf chart? And return. There we go again. Now notice the stem and leaf chart gives us some interesting analysis of the data. It tells us most of the takeoff temperatures were in the 60 or 70 degree range, and there was only one in the 30 degree range, whatever that's worth. What if we wanted to actually put in a question for help? What is a stem and leaf chart? How does it work in R? We can actually run this, and here's R's help. Comes up. You can get help on just about any R command. Help looks the same. It's not particularly friendly, but very usable. Let's close that. Let's now go to a dot or strip chart. And I'm going to do this piece by piece. In this particular case, I started with my chart over here. Let me bring it over. It's came off the screen. If I can. Here it is. I'm now going to add a title to it. Some graphics commands can actually be used to add to a current chart. There's the. Now I'm going to add a horizontal line at 0 and some text. There it is. Most R commands involving graphics erase the old graph when you execute them. Now I'm creating a histogram. There it is. But here's the rug command, which actually can add the actual temperatures to the histogram. Here you have it. Let me close this chart a little bit. How about a bar plot? First, a simple bar plot. Bring it over. And now what I'm going to do is I'm going to redo the bar plot, but this time in color. There it is. Box plots are very useful. So let's actually create a box plot. Notice all of the graphics commands are pretty similar to one another. This main equals something in the main graph command generally is the title of that plot. You can add that later, but usually it's easier to put it in right at the beginning. So here's my box plot. These are kind of useful. Here is basically the minimum value. Here's the median. Here's the first quartile, the third quartile. This is the maximum temperature. This shows that there is an outlier in the low temperatures. It happens to be our last flight of the Challenger. And here's a pie chart, which is easy to do, but the general position of most statisticians is don't use pie charts. They can be very misleading. Let's close this up, because now we're going to... Okay, by the way, for whatever it's worth, here are the executed commands. Sometimes you want to clear the screen, and if you use Edit and Clear Console, lo and behold, new screen. The variables are still in here. It's just cleared what we have. Now, here's temp again, just so we see those temperatures. Now, here are some numerical quantities. If you take the sum of all the values in temp and divide by the number of values you have, in this case it's 2371 divided by 36, you get the mean temperature. Now this is R. R is a statistics program, so it's going to have a built-in command for any statistical type value, and mean is one of them. And the R command is actually mean. Here's how I could define a variable MT, which is the mean of temp, and lo and behold, same value. You say, hey, temp isn't sorted. What if I want to look from lowest to highest? I can define temp S as just sort temp. Here it is. Notice lowest to highest. And the median is the middle value. In this particular case, where we have 36 values, the mean will be the median will be the middle between the 18th and 19th value, which is 67.5, right over here. Remember, we've sort of seen this before. I could take the table before, and if I divide by the total number of observations, I get the proportions for each of these categories. Notice 38 to or 39% of all the flights occurred in the 60 to 70 range. I usually don't like to have so many decimal points. It mixes me up. So you could take CT prop, which is the name of the variable, and round it to 3 places. Same things, but only 3 digits of accuracy. If you eliminate values from the left and the right of a mean, you get what's called a trim mean. We have 36 values, and if I wanted to eliminate, well, actually, first let's look at these sorted temps again. This command, it's the mean, but this add-on of trim equals 2 over 36. Actually, it eliminates the low 2 values, 31 and the 40, the high 2 values, 83 and 84, and takes the mean of what's left over. And notice this was a little bit different from the original mean, which was 65.86111. I could take 5% of the values off on either side. Be careful, because there isn't exactly 5% of 36. So R will do this using a certain algorithm. We can also eliminate just the first and the last values. Here it is. And the R command max and min gives the maximum and the minimum of the temperatures. Now, there are various measures of variability in R. Let's actually clear the console again. One of them is called range. Now the range is actually the maximum value minus the minimum value. There is not a built-in range command in R that does this. So in our particular case, 84 minus 31 is 53. There's our range. If you want to see a whole bunch of summary values at once, if you have a vector of numbers, use the summary command. See summary temp? It gives you the minimum value, the maximum, the median, the mean, and the first and the third quartiles. The quantile command basically gives you quartiles or percentiles. Here are a few of them. And the interquartile range is the 75th percentile minus the 25th percentile. The variance actually is the sum of the squares of the temperature values minus the mean of the temperature, and then we divide that by the number of values minus 1. In R, this actually is done pretty easily. Here are the temp values. If I look at temp diff, this is the temp minus the means. R automatically subtracts the mean, which we calculated above, from each of the temperatures. If we now square this is now called temp diff 2, we actually get element by element squaring. Let's look. Now I'm going to sum all of these squares up. And this is the sum of the squares. And now I'm going to just divide by the length of temp, which is 36 minus 1 or 35. And I get this. And this is how you could calculate the variance. But, once again, statistical program. There is a built-in command for variance. It's called VAR. Watch. And run that. Same value. Standard deviation is the square root of that. But notice SD is a standard deviation command. Here's another way of calculating the same number. It used to be valuable before computers. Notice the same 147.83. Be careful, because if you use the range function in R, it just gives you the 31 and 84 as a vector. The range in statistics is actually 84 minus 31, which is not built into R. But I could define a command called range temp, and here it is. And last but not least, a box plot is really a useful thing in R. Here it is with horizontal equals true, so the box plot winds up being, once again, I have to bring it over into this picture. And here's my box plot. And that's the end of our video.